Sit comfortably with open your eyes. Take your hand, right hand, put on your chest, heart. 6 times we are doing a relaxation. Inhale through the nostril, exhale through the mouth. You relax all the bodies, head, shoulder, face, everything with smile. If you sit in earth, in floor, you feel the energy, earth energy. Now through the nostril only, 6 times you are doing. Observe the heartbeat. Through the nostril, inhale slowly, exhale through the nostril slowly. Each cycle you are getting very, very slow. Always keep it smile in your face. Okay. Everyone get relax. Okay. Verma, Patel sir, Rajaswan. Okay. And paper two. So paper two only they are asking direct questions. Are you understand? Paper two, they ask direct question. It's a very simple, but we have to understand the calculation. From the ask different industry. Clear, Verma? Patel sir, Rajaswan.
Yes, sir.
Yes. So when you practice in the book calculation, the question paper you can do maximum 80%. You study the question paper, same. It's a direct question. Na? Everything direct question. But paper 3 is different. Maximum 50%, 50% is a direct question, 50% is indirect question. Here not like that, paper 2. So directly they asking the what is the heat and how much saving. So everything they asking directly. So what is the struggle? You have to understand the concept, very important. You make the diagram clearly. So level 1, what is the level 1? We have to create some level. So first level 1, level 2, level 3. Only 3 things we have to make it. So level 1, you have to follow only the diagram. Whatever you're reading the concept, you draw the diagram. Step 1, step 2, step 3. You have to follow like this. Okay, I will show that. You can easily understand. Can you see the screen?
Yes, sir.
Yes. Step 1. When you read the we have to follow 3 steps. This is a level 1. We have to create level 1, level 2. So step 1. Diagram. That means concept map. Step 1. Step 2. Mark the data. Step 3. Write whole formula. Step 4. You have to highlight which data to find. This is a level 1. Are you understand? You have to write whole formula. Step 4, you have to highlight. Na? You have to highlight the which data to find. It's very important. Na? The 4th step you have to follow. Level 1. So level 2, each questions after once completed, level 2, second round. You have to do what you have to do? Second round. Second round, what you have to do? With using calculator, do the calculation. Step 6. First one, you have to understand to find EC data or which one mandatory to find, to calculate next process. Using the calculator, do the calculation to find EC data. Which one is EC? You can find it quickly. Or which one mandatory to find, to calculate the next process, next step. We have to follow the next steps. Step 6. Step 6. Step 6, what you have to follow? Apply the data. Final requirement. Step 7. Check unit properly. Unit must. Check properly all the unit. Here is a unit conversion very important. What is important? Unit conversion. Any unit can secure any unit conversion. So unit conversion very important. Clear for level 1, level 2. Okay, first round, this is round 1. You have to follow this one. Round 1. So round 2, second time you have to follow this is why I am telling like this now. Once you do this step 1, step 2, step 3, step 4, automatically you are going to for next calculation. So what will happen? That mind always working for other process. Are you agree this one? Your mind always working for what we have to do, other process. Same like this going on. So level 2, you have to do it. Level 3, I will do the calculation. If you not find out, I will do that. Only level 1, level 2 each, you have to make it this like this. Everything simple, make it simple one. Clear? Okay. So I will explain the simple concept for each questions. Okay, this is a already chapter 1 to chapter 2. This is a book calculation. Already I have explained this one. So again I will explain. The chemical plant available is a ABFC boiler with the following specification. What is the capacity? This is a 10 per hour means Q. This is a press. This is a steam temperature. Na? The fuel fired with 35% ash content. Okay, only they given the ash content. They don't give anything data for fly ash, bottom ash. Are you agree this one? So gross calorie given, theoretically are given na TA. Hydrogen in the fuel given na. What do you have to find out? Anyone tell me quickly? Verma, Rajraj Solan, Patel sir, Karthik.
Hydrogen fuel that.
Only we have to find out. Only the hydrogen in the fuel. Okay, clear? Yes. Next one is a specific fuel classes, 0.24. And the specific heat of superheated water vapor, this CP. This CP for use for flue gas.
Flue gas.
This is very important. You have to find out heat loss, flue gas. Operating temperature given na, flue gas excess temperature. What is this one? Operating temperature. Is a TF na? Yes, T is a TA.
Yeah.
XSR given na, EA, percentage XSR.
Percentage.
Okay. Radiation loss already given. What is radiation loss? This is L6. Ambient temperature given. Sorry, this is a. Sorry, this is a H. Feed water temperature.
Kilojoule calorie per centigrade. So it's.
Yes, exactly. There is a ambient temperature.
Yeah.
Now they asking indirect method. Already we have explained na simple indirect method.
Yes.
100 minus. What are the loss you have to do it?
L1, L2, and L6 also only find out the L6 is given. So we are find out on the L2, L1, and L2.
L2 already given radiation loss. L6. Clear? Nothing. They didn't give anything na.
Yeah.
So simple way you can find out now. Only 3 formula you have to apply. You have to already they given the theoretical error also. Are you understand? No need to make it anything.
No make it. Yes. This is
Clear. Simple calculation. This is simple calculation. You don't follow any previous steps. So next what they asking? Feed water temperature, the increase 1052. The increase how much temperature? The feed water temperature is 105 and the steam 65 kg. and 500 degrees Celsius. What is the hourly coal consumption? Total heat of the steam, CC and 500. That is means they change the K calorie. Clear. They change the K. What is the K calorie here?
This is a 6, sorry.
Yes, they are asking, yes, if you see the boiler efficiency, you have to find it. Simple calculation. If the feedward temperature 105, same temperature, feedward temperature, and the steam produced 60 kg per centimeter square at 5,500 degrees Celsius, what is the hourly coal consumption? The total heat of the steam, what is the heat of steam? 817 K calorie. What is the formula? You have to apply, na? Boiler efficiency.
N into
Q into H minus HF divided by Q into cross caloric value. So you find out na indirect method boiler efficiency. Only they asking Q. Clear?
Yes.
So Q steam. What is the steam? Q. This is a Q na 70 ton per hour.
70 tons per hour.
H 817 minus what is HF? 105.
05.
So divided by cross caloric value how much? 4,000 K calorie. Boiler efficiency how much? Whatever value you have to make it. Okay? Into 100. Simple, you can calculate Q. Okay? This is what is the main unit? Unit very important. Na? What is unit? What is the unit?
kg.
Kilojoules per kg.
Yes,
kg
kg
per
per hour.
Kg per hour.
So because they don't give anything operating hours. Okay, first question you can do it now quickly. Now you get clarification.
yes, sir.
Okay, every time you have to reference. If you already know that, no issue, you have to make it very fast. Are you understand? Na? You have to make it everything very fast. So next question. The oil-fired reheating furnace has an operating temperature around 100 degrees Celsius. This is a furnace, na?
Correct.
Okay, average furnace oil consumption 440 liter per hour. So once you read, what you have to do? Conversion. What is the main point? So always remember every question, unit conversion very important. What is important? What is important?
Unit conversion.
Unit conversion. Now you understand, na? You have to convert, na? Convert, unit convert.
Kilogram per hour.
Yes.
Yes.
Multiply by
The
space.
hint point. The flue gas exists temperature, air free heater. After the air free, what they doing? After the air free heater. So 300 degrees Celsius. Okay, combustion of the combustion air free heated from ambient temperature 35 to 200 Celsius through the air free heater. Other data given. What are the data? The specific rate given, caloric value given, O2 value given, theoretical TA given, na? TA. So once you read the TA, what is the purpose of TA? Tell me quickly, what is the purpose of TA?
To find surface heat loss.
To find
Theoretical air.
so what
To
are
find the
the
automatic.
yes sir, theoretical air, what are the requirement? Everything you have to find out. Na? Theoretical, what is the main once you read the theoretical, this theoretical where they using simple way to find some equation. The equation using a actual air supply, na? The actual supply for using for to find flue gas mass. So everything sequence. So same XSR, what is the purpose? XSR. First XSR. Once you read the XSR, what you have to understand? This useful find out the actual air supply. It is helping, na? Both need help. Then only you can find out the actual air supply. Then going for to find flue gas. Clear? The specific heat of the air. They given the air. Are you understand? They give separately air, flue gas. You have to understand 0.24, 0.23. So find out the sensible heat. What is the sensible heat? Tell me quickly. See, everyone need to answer, very important.
MCP delta T.
Yes, what is sensible heat?
A bit change in temperature that causes.
Yes, that it means increase the temperature for air carried away by exhaust gas. So flue gas always giving sensible heat. Okay, next, and heat recovered by the combustion air. The find out the sensible heat carried away by the exhaust gas. They asking sensible heat carried away. And heat recovered by the combustion air, K calorie. As a percentage, you have to calculate. How much percentage? Now clear? How to calculate? Two things you have to calculate. What is the two things? One is a,
Sensible heat.
so what you have to do? Draw the diagram now. So first step, what is the first step? The one question I will explain. What is the first step?
Draw the diagram.
Draw the diagram. Yes. This output. This is a flue gas. This is a flue gas. Here is a air free heater. This is going out. The furnace. F. I am giving the fuel input now. First step, you have to draw before air filter, after air filter. Are you understand now? Okay. Before air filter, after air filter. It's very important. Before air preheater, this after air preheater. The fuel, air, flue gas. What is the temperature? Operating temperature 1000 degrees Celsius, na? Furnace. Furnace 1000 degrees Celsius, na?
Yes.
Yes, that means flue gas temperature how much? Here?
300 degrees. 300.
Clearly you have to tell. Oil fired refurnace operating temperature around 1000 degrees Celsius. 1000. Degrees Celsius. Is inside 1000 means before air preheater. This is also 1000 degrees Celsius, na? Yes. Okay. Next one, what you have to do? After furnace. So after furnace, they install the furnace, na? This is data, but generic data. This is generic data. This we have to understand. They install the air preheater. They are giving the fuel. So output going on, air preheater. Now the temperature, the average furnace oil consumption liter is a 440. The flue gas exists temperature after the air preheater. Here is the temperature how much? 300. Okay. This is a TF. Any doubt? This is a TF. It's after. So what is you have to make it? Any idea?
HA.
You have to make it point. A point, B point. It's a temperature. This is A point. This is a B point. Same also air going na. What is the purpose of air taking? They are giving here. This is air. This air in, air out. This is also same, na? A point, B point like this. Potential difference, same like this. In, out. So what is a flue gas? Now here is a both mixing, na? Not mixing. The connection. What are the connection available here? In air free heater? Flue gas and air. Connection available. The heat transfer available. Flue gas. Heat loss equal to heat gain. So which one is the heat loss? So anyone tell me quickly? Already done this calculation. I explained.
Flue gas is heat loss.
Heat loss,
Flue gas.
flue gas. Heat gain,
Yeah.
Yeah. Okay, what is the temperature of the combustion air? Free heated. How much free heated? 35 to 200. So what is it? This is T1, 30 degrees Celsius. What is the T2? Here output
200.
200. Okay. The other data, the given. So average O2, how much? Average O2,
14%.
14%. Theoretical air requirement, 14 kg of air per kg of oil. So what do you have to do? You have to calculate mass, na? What you have to find out? You have to find out actual air supply and flue gas. Yes. Here you need to find out mass of air. Are you understand? This is you have to find out the actual air supply. Here flue gas you have to find out flue gas mass. Mass. MF. This is you have to find out. MA you have to find out. Clear? Oil already did na? Already what is the oil? 440 liter per hour. This is what you have to do. This is what you have to do. Tell me quickly.
kg per hour.
Yes, kg per hour. To find out kg per hour. Unit conversion.
Fuel conversion.
Kg per hour. Next, what you have to do? This is data complete, na? Data.
Yeah.
Step 1, step 2 completed. Level 1. Step 1, step 2 completed. What is the next step? Step 1, step 2 completed.
Formula.
Step 3, formula. So what is the whole formula? Just write it. Whatever the formula available, you have to write it. What is the whole formula? Simple way. Heat loss equal to heat gain. So air heat gain equal to M. Air is M into Cp into T2 minus T1 delta T. The simple formula MCP delta T. So what is other formula? For flue gas,
You need to
Heat-
find the O2 and
heat loss. MF into Cp into same delta T. Same you can make it. What you have to make it? Here is a very important. After free heater, this is very instruction. This instruction, what they are saying, find out the sensible heat carried away by the exhaust gas. How much carried away? Here 300 degrees Celsius, na? This is everything after free heat. So this is 300 degrees Celsius. What is ambient temperature? The distributed here. This is the loss. So TF minus TA. This is after free heater. After air free heater.
So in this case, one temperature has to be 1000 degree.
Wait, one time. Heat loss. They ask heat loss, na? The find out sensible heat carried away by the exhaust gas. Here,
Yes.
here, na 300 degrees Celsius. This is carried away, na, for blue gas. And heat recovered by the combustion air. How much heat recovered? They are asking kcal per hour. You have to note it. Kcal per hour. How to find out? What you have the data? What are the data required here? What are the data required? Step 4. Step 4. What are the data required? Tell me quickly. What are the data you have to find out?
Theoretical. Sorry,
MA and MF, na?
Then difference you have to find out.
Are you understand? MA and MF. Clear? If you any doubt, tell me, then only doubt clarification. If you silent means I could not understand. You understand or not?
So in previous case, that 300 degrees Celsius direct sensible heat loss we are doing.
Ah, yes.
Okay.
Find
No
out
any
sensible.
calculation required.
Yes. They don't ask anything before air preheater. Okay.
Mm-hmm.
After they asking everything, flue gas temperature after preheater 300. They mention clearly, then only you have to do the calculation. Karthik, understand or not? If you understand, tell me yes. Otherwise, not understand, that also very important.
Okay, sir. Just I
Okay.
need to solve the only understood
no,
the concept, sir.
Okay. Okay, step 4, what do you have to do?
Calculate the mass of air and flue gas.
Yes, MA and MF. Clear? MA and FF. How to calculate?
Mass.
So you done a lot of calculation, theoretical calculation, actual air supply calculation. The data already given a theoretical air.
Yes, sir.
Then why getting, what is the mass of air?
Actually, the supply is equal to theoretical air plus 1 plus
Yes.
percentage plus air.
Mass of air means the actual air supply. Clear? Mass of air means actual air supply. What is the meaning actual air supply? Theoretical air 1 plus
Percentage excess air.
excess air. So percentage excess air. This is we have to do it. Okay, what is the next one?
Mass of dry flue gas.
This is complete, na? Mass of dry flue gas, how to calculate? This is everything
Actual
for.
air supply plus 1.
This is everything for. This is everything for. This is everything for 1 kg fuel. So total mass of air, how to calculate total mass of air?
Multiply by the mass of fuel.
Yeah. So actual air supply kg per kg of fuel into Kumar sir, are you understand that, sir?
Kg of fuel.
Sir, yes, sir.
And
Kg of fuel.
total kg of fuel. Fuel input. So next, what do you have to do?
Mass of dry flue gas.
Mass of dry flue gas. So how to calculate mass of dry flue gas? Total mass of dry flue gas.
1 plus actual air supply.
Mass of dry flue gas. equal to always remember actual air supply plus 1 into total kg of
Fuel.
total kg of fuel input. Then next calculus, what you have to do?
Difference. We have to
Yes,
find.
simply you have to MCP delta T, you have to apply, you have to calculate, and you have to find a percentage of energy input. Are you understand the percentage of energy input? How to calculate the percentage of energy input? What is energy input? What is energy input?
Q into GCV.
Yes, this is energy input. How to calculate the percentage? Any idea?
Difference divided by input.
Yes, the percentage of heat loss, heat gain for air equal to heat gain divided by input energy into 100. This is simple calculation for both. Now finish everything. If you understand what is the tri-flue gas, what is the theoretical air, what is the actual air supply, then only you can easily understand, clear. If you understand the actual air supply, how to find out, how to theoretical air, they already given theoretical air. No need to find out now. Modak, are you understand?
Sir, good morning.
Yes, good morning. Understand? Are you understand?
No, sir. Actually, sir, I just joined, but step by step, I
Okay.
understand.
Okay, no see. Okay, I will upload this one. You have to find out everything. Okay.
Yes.
So next calculation.
Sir, one thing I want to ask, just a doubt for me. For finding this flue gas, MCP delta T flue gas. So what will be the T1 and T2? 1000 degree and 300 degree?
Already they have mentioned how much carried away. Carried away. They mentioned clearly. The carried away means by flue gases, by exhaust gas. What is exhaust gas? What is exhaust gas?
Flue gas.
Flue gas, na?
Okay, so
What
this
is
is the
what is the carried away? Carried away. What is the meaning of carried away? Here is a 1000 degrees Celsius.
yes.
Here is a 1000. They are asking carried away. What is the meaning carried away? Which one is carried away? Here carried away, here carried away.
Upside.
Upside, na?
filter.
Yes, this is a 300 degree. What is the ambient temperature?
35.
Yes, 3A. What do you have to do? Carried away. Difference between carried away temperature minus TA, na? Directly going to mixing with the air. This is air free heater. Air free heater. This is a flue gas. This temperature 300 degrees Celsius. This is directly mixing with this directly mixing with air, na?
Ambient air.
Yes, this is a TA temperature. So 35 degrees. 30 degree or 35? 35.
35.
So why this?
So both are mixing. What will happen? Energy loss, na?
So why this 1000 degrees Celsius is given?
They are already told, na, furnace operating temperature 1000. I mentioned here inside. Operating temperature. You have to read the question paper.
What?
Oil fired heating furnace has operating temperature around 1000 degree. What is the meaning?
The inside temperature is 1000 degree.
Yes, this is 1000. Furnace operating 1000. Here coming flue gas is 1000. We are inside the air free heater. Then after air free heater, it exists 300 degrees Celsius. This is a carried away.
Carried away.
If you mention before air free heater, without air free heater, you can find out. You can find out how to find out without air free heater how much energy loss by carried away by flue gas.
1000 minus.
Without air free heater. What
1000
is the flue
minus
gas
that
carried
is-
away?
1000 minus ambient air temperature.
Here you mentioned how much flue gas carried away.
Understood. What I was thinking, sir, I have to minus 1000 minus 300 because
How
we
is
are
how is possible? Because they mentioned air free heater. They didn't mention anything. Find out sensible heat carried away by the exhaust gas. They mention anything?
no.
But
No.
sir,
Yes, sir. Tell me, sir.
in both cases, the T1, T2 minus T1 is also considered as a 35 degrees centigrade.
Yes,
Because
sir.
of 300 minus 300 minus 35 and 300 minus 200 minus 35.
Yes, sir.
For air preheater, after preheater, we are considered the delta T is equal to 200 minus 35, and before APH, we are considered 300 minus 35.
Papa.
No, sir.
1000 minus 3.
No, sir. Here is a 1000 degrees Celsius is a furnace operating. I draw the diagram before
Furnace
air
operating
preheater.
is 1000 degrees centigrade, but after furnace exhaust gas is
Exhaust
not
gas.
1000. Is
No,
a
sir.
1000 degrees centigrade.
No, sir. Here inside, you understand point is very important. You make the
Yes,
point.
that is the inside temperature, the 1000
That's
degrees.
instant degree. This is here before air heat. How much temperature? 1000. Na?
Okay.
You have to draw the diagram. What is the diagram? This is air free heater. Air free heater. This air free heater. Na? Can you
Yes.
see the screen clearly?
Yes.
Yes, sir.
So this is a flue gas in. Na? This is 4 point available. 4 input. This input 1 main input. This is air input. Air. This is air input 1. Same like boiler. Here flue gas input output 1. This is air output 2. Clear? Any doubt? What
Yes.
are the point? Simply you have to mark point A, B, C, D. Clear? The air temperature how much? Ambient temperature 35. Na?
35.
So what is here in before air heater? What is temperature of flue gas? This is a flue gas.
1000.
Na? 1000. Clear? Understand? Here how much temperature? 300. Here temperature how much?
200.
200. Suppose, what is the main thing? Suppose they don't give anything to find out the mass of air. Then you can use the heat loss equal to heat gain formula to find out mass of the air. Are you agree this one? Already we have done. Na? Heat loss equal to heat gain.
Okay.
So this point is very important. They already mentioned theoretical air. So you have to find out the actual air mass. What is the main thing you have to find out? Both case you have to find out. Which one you have to find out? Both case.
In
Both case, what do you have to find out?
Mass of air and flue.
mass of air and mass of flue gas.
Yes, mass of, this is air.
Yes.
This is a mass of flue gas.
Flue
How
gas.
to, what is the common point?
Common point is a
Actual air
T-
supply, na?
actual air supply. Sorry,
Delta T
Actual air supply. This is actual air supply plus
plus
1. Actual air supply plus 1. So actual air supply plus 1. Clear? Everything for
kg of fuel.
1 kg fuel.
1 kg of fuel.
Both things for 1 kg of fuel.
Am I audible, sir?
This is everything for 1 kg of fuel.
Sir, am I audible, sir?
Yes, sir. Tell me, sir.
Sir, here I have one doubt, sir.
Yes, tell me, sir.
There is a formula. What is the heat loss and flue gas? Heat gain.
Sir, your voice little bit low, sir.
1 second, sir. Oh, okay.
Tell me,
Hello.
sir. Yes, sir.
Now okay, sir.
Yes, sir. Tell me, sir.
Sir, wow. Heat loss in flue gas equal to heat gain in air, correct, sir?
Sir, still no, I could not hear, sir, your voice.
1 second, sir.
So, which one you have to understand, sir? Now clear na all point.
But sir, we are consider in calculation both cases. First of all, we have find out the hello.
Yes, sir. Tell me, sir.
Hear my voice, sir? Yes.
Yes, sir.
For heat output, we are consider
one thing you have to understand, every question you have to work out, you can get all the answer. If you are seeing the any problem, what will happen now? So always thinking. So thinking, what will happen? Creates more problems. So you have to draw the diagram, first work out what are the formula, what are the things. Automatically mind get calculation, everything clear. Are you understand?
yes.
Once you draw the diagram, data, and do the calculation, conversion, everything, you start with this one. See, everything action only. If same thing you are seeing after 1 day, after 2 days, after 3 days, you are always getting confused. What is the reason? You are not doing, just seeing.
Yes.
Just seeing the things, everything create mess. So doing the things, everything very easy.
Yes, sir.
So what is the main purpose? What you have to do? Simply you have to follow the 4 steps.
Okay.
Step 1, step 2, step 3, step 4. Just leave it. Automatically your mind find out. So don't think too much. Everything simple calculation. What is simple calculation? See, same mass, heat loss equal to heat gain, simple formula. Already you know how to calculate the actual air supply. This actual air supply for 1 kg of fuel. You calculate it for total kg. Total kg of fuel, how much? 440 into 0.92.
0.92.
And then you multiply. What is the flue gas? It will increase plus 1.
Plus 1.
Say actual air supply plus 1 into
42
that is
plus 1.
finish.
Yes.
That is finish.
After that,
After
mass
that,
of-
yes, this is what is MCP delta T, MCP delta T. They are asking the energy input percentage value. Then they divide everything. That is very easy calculation. This is a 10-mark calculation.
Yes, sir.
So you have to do.
But sir,
work out.
My
Yes,
question is, hello,
Yes, sir.
Sir, my question is, we are find out the two heat sensible heat less carry out by the dry flue gas. At that time, we consider 300 minus 35.
Yes, sir.
Heat gained by the preheater. Heat gained by the preheater. Yani it means heat absorb air preheater input air preheater. We have considered 200 minus 35.
Yes, sir.
So in both cases, when we are find out the MCP delta T is at that time we have considered M is equal to 42 multiplied by 405. At that time, consider 170 and specific gravity 0.24. SP is 24 and 200 minus 35 in first case, and heat sensible heat less carried out away by the dry flue gas.
Yes, sir.
Means dry flue gas exhaust. We have to consider at that time consider temperature difference with 35, and same is considered as the 35 with 200.
Yes, ambient temperature is always common, sir. This ambient temperature. This ambient temperature always this mixing with
Yes.
ambient.
Okay.
So this is a common. This already.
Okay.
What
So-
is other doubt, sir? What is the doubt, sir?
Doubt is 1,000 degree. Why where we utilize 1,000 degree?
Sir, the mentioning is a furnace operating temperature, generic data.
Okay.
if suppose mention how much heat loss without air free heater. Without air free
Without air
heater.
free heater, yes. Without air free at that time, delta is 1000 minus 35.
Yes, sir.
Okay. If we are not utilize the APH, at that time we consider 1000, delta T is equal to 1000 minus 35.
Yes, without air free heater. They mention
Okay.
in questions.
Okay. I got it, sir.
Yes, you understand? Without
Yeah.
here not mention anything. Find out the
Yes.
sensible heat
Sensible
carried
heat.
away by the exhaust gas.
Exhaust gas, yes.
Okay, they mention, they don't mention anything, installation, nothing. The air heating furnace, average temperature, everything, average oil fuel, this. The full gas exist temperature they mention after the air free heater.
Yes, sir.
The compression air free heater from ambient temperature.
Ambient temperature 35 to 200.
Yes. Why
Then
I
sir,
mentioned, why I
200
mentioned
degree
here,
Celsius will not be used.
wait once I will complete. Why I mentioned here, air free heater without air free, you have to understand this one.
Yes, sir. Okay.
Otherwise, another question they'll ask like this.
Yes.
Okay. Any doubt?
No, sir. Clear it.
Okay. Tell me, Verma, quickly.
This 200 degree Celsius will not be any use in the calculations. We have to calculate by 1000 degree and 300 degree.
Why are every time you are messing? What is the problem? Clearly tell me. 200, you understand 200? They mentioned data, air free heater, 200 minus 35. This, what is this data they given? Air, na?
Yes.
This is air already mentioned here, na? 200. Verma, I am asking you, Verma, you asked the question.
Yes, sir.
What is the next question? They mention, here also they mention air free heater. After air free heater, flue gas also mentioned 300. Here 300. Na?
It is 200.
Yes.
So data is given clearly. You have to draw the diagram clearly.
Yes. First of all, okay.
So what you have to do? You have to do the diagram. You have to make it diagram. Every time you have to make it diagram.
Okay, sir.
Okay. Next one is this question you have to follow. This one. What is the efficiency of billet heating furnace with an output? What is the output? They mention output. What is the output? Every time you have to make it on box. This S2. What is the box? This is a box, na?
Yes.
This output how much? 50 ton per hour. What is they mentioned? Efficiency. This efficiency I mentioned, 32 degree.
32.
Find out specific fuel consumption liter per ton. What they mentioned? The specific fuel consumption. This is very important. 1 mark they all. So any material, any furnace taking specific fuel consumption. Liter per ton of billet heating. What is mentioned? Billet heating. How much billet heating? 50 ton. Are you understand?
Yes.
15 ton. And total fuel consumption per hour.
Q.
So, okay. So, initial temperature how much? Initial temperature here is a material na? Input.
Yes.
What is initial temperature? 50 degrees Celsius. Here increase the temperature. How much temperature increasing here?
1150.
1150 na? So here also inside also 1150 in furnace inside.
Okay.
The specific heat given. All you understand specific heat.
Yes.
What is the density also given na?
Yes.
Crash caloric also given. What is the formula? Heat in the stock
divided by fuel input.
Okay. Output energy divided by input is same like this.
Yes.
Simple formula you have to apply. What is the full data? Efficiency data equal to heat in the stock. What is the formula? MCP delta T.
CP delta T.
You have to understand what is the M, what is the CP, what is the delta T. Delta T, which one is the delta T?
1150 minus 50.
How much? 1150. What is the Q not given? Na?
Q not given and GC.
Yes. Cross caloric value given. Na?
Yes.
Into 100. You have to identify which one is given, which one is not given. So this is given. Everything given. This is you have to find out. Now clear?
But sir, here
Any doubt? The specific fuel consumption. How to find a specific fuel consumption? Then total fuel consumption you have to find out now. They are asking liter per hour. They are asking liter per hour. How to calculate? So what is the quantity? What is the unit here? What is the unit?
We can get a kg per hour, that we have to convert to liter per hour.
Yes, this kg per hour na. So everything you have to convert liter per hour. How to convert liter per hour? How
Density
to convert
they
liter
given.
per hour? So what is the kg per hour formula?
specific rate liter per hour.
Kg per
hour.
kg conversion always
Liter per hour multiplied by specific gravity.
yes, here mentioned density.
Density multiplied by density.
Here simply how much liter per liter they given. So you have to find out liter. So first value is a liter per hour. Simply you have to write liter per hour into this is into or divide. This is very important. Into or divide. Into or divide. Which one you have to use?
Right. Liter per ton divided by 1000.
For
Divided
unit here you always understand kg per hour. It is coming kg per hour on the top side.
Yes.
It's a density also kg per hour coming on the top side. So you have to multiply. This is very important. Density. If you don't understand, you have to understand the unit, liter per hour. So what is going to cancel? Liter cancel. Liter cancel. Then kg per hour available. This is unit conversion.
Okay.
Okay. Now they asking liter per hour. So liter per hour, what you have to do liter per hour? What do you have to do liter per hour?
Need to divide it.
In
Liter per hour equal
liter per
to
hour equal to
yes, kg per hour divided by density.
density.
So suppose for a specific gravity given, you have to multiply for kg per hour calculation. See, everything you have to make it like this formula. So for suppose the given specific gravity, how to calculate specific gravity? Kg per hour equal to liter per hour into specific gravity. Clear? Then liter per hour equal to this, right or wrong? This is okay? Two kind available now. One is density, one is a specific gravity. Any doubt? Unit conversion? Any doubt unit conversion?
No, sir.
No, no. Now understand? You are converting liter to kg per hour. You have to multiply with the specific gravity. If you are given the specific gravity, you multiply. Now given density, just multiply density.
Yes.
Okay. Next is a S3. What is S3?
Boiler output 5000 kg per hour of billets. Yes.
Yes. Here is a furnace output. How much? 5000 kg per hour pellet. Thermal efficiency is given 25%. The
Yes.
specific heat of the pellet 0.12. Billet enter the furnace temperature 40 degrees, same 40, at leave 1200. Calculate the hourly oil consumption. Liter. They asking liter. Cross caloric value is a oil 9200 kcal per liter. They given the liter. Are you understand?
Yes.
They given the liter. Here, what is the unit here? Cross caloric value per kg. So here they use the kg, so you are to using everything kg. Now they using that liter, then what you have to do?
I have to we have to change kg per hour to liter per hour.
Liter per hour. So directly you can apply. Yeah, for S3, what you have to do? S3. So you understand the box? What is the diagram, everything? Understand? It's a 25% efficiency. What is the 5,000 kg per hour? Material. This is how much going on here. How much going on here? Same 5 guys. What is temperature?
1200 degree.
Yes. What is the temperature? 40 degree.
40 degree.
1200 degrees Celsius. So 25% efficiency. They are asking how much oil consumption in liter per hour. So what is the formula efficiency? Same efficiency.
Heat input divided by
MCB delta T
delta T
into Q into cross caloric value into 100. Here bottom size, always they ask liter, na? They are given the data as liter. So always use liter. So what is the efficiency? 25%. So you have multiple 5,000 into CP how much? 0.12 into what is the temperature difference?
11,000, 12,000 or 1200 minus 40.
40. Here Q. Q is liter per hour. Cross calorie also liter per hour.
Liter per hour.
So you keep it like this. Then what is the unit? Here unit, what is the unit? This is
kg
you
per
have to
hour.
liter. This is a liter.
Liter per hour.
This is also liter per hour. So that you are using liter per hour. So liter per?
Liter per hour.
Yes, K calorie per liter. Sorry. K calorie per liter. So you have to, for now you can find out now Q easily. Any doubt? This one?
No, sir.
No. So next one, reheating furnace. Reheating furnace output 10 ton per hour. Billets are heated from 50. Same concept. The oil consumption 700 liter per hour. The specific gravity given. Net caloric value given. The specific heat of billet the given. Find out the thermal efficiency. Simple formula. Same formula you have to apply. Clear this one? Simple calculation. Are you okay? Not okay?
Hello.
Yes, sir.
Yes. Yes.
Kumar sir, Modak, are you available? Verma sir?
Yes,
Verma
sir.
available or not? Karthi?
Available, sir, available.
Yes, now clear this calculation. Simple formula.
Yes, sir.
Sir,
Yes, Patel sir.
sir, my confusion is in some question they mention GCV and some question they mention NCV. And GCV formula from the chapter number 1 we know very well, but they mention the NCP. So which data we should use?
Always both data they mention, you have to use gross caloric value. Here they mention net caloric value. They will clearly mention. No need doubt. Here they mention everything. Here data they mention everything clearly. They mention or not?
So that's one. Yes, sir.
Now they mention clearly. So no need confuse. Every data they given clearly. If only they given net caloric value, There also mentioned, they find out the thermal efficiency of the furnace on net caloric value basis.
Okay, sir.
The every data they giving clearly without any doubt. Don't get it any doubt. So don't think that is no need. You have to make it. Whatever the data given, you have to make it. Now everyone clear?
Yes, sir.
Yes, Varma.